This video is going to cover comparing and scaling problem 2.2, which is going to cover ratios versus rates, making rate tables, and writing and graphing equations. There is quite a bit in this video, but it's going to be helpful to us to see it all at one time instead of breaking it up. Let's first talk about ratios versus rates. We've been talking about ratios throughout this book, and we know that ratios are comparisons of two quantities that have the same units. An example of ratios that we've been using have been something like a juice mixture calls for 1 can of concentrate to 3 cans of water. Notice here that we are comparing cans to cans. Even though it's cans of concentrate and cans of water, we're still comparing cans to cans. They're the same units. We call that a ratio. On the other hand, we could compare two quantities that have different units, and this we would call a rate. An example of a rate would be in the 2015 regular season, the Pittsburgh Steelers scored 410 points in 16 regular season games. Notice here that we're now comparing points to games. Those are two completely different units, so we call this a rate. Take a look at these problems, see if you can identify them as a ratio or a rate. Okay, the first one, gas is currently $2.09 for 1 gallon. We're comparing dollars to gallons, so that is going to be a rate. Second one, Mr. Barge bought 200 pencils for $20. Here we're comparing pencils to dollars, so that would be a rate. In the last one, in his coin collection, Fred had 29 dimes and 77 pennies. Even though here we're comparing dimes to pennies, we consider those both types of coins. So this is going to be a ratio. We're looking at his coin collection, so they both fall under one kind of category. Dimes and pennies are both coins, so that is a ratio. Okay, we're going to shift gears here a little bit and talk specifically about rates. And this is the situation we're going to deal with here. Melinda is in charge of ordering cell phones for her company. She has the choice to go with MR Talk or MRS Text Company. Each company sells plans based on the amount of data they use each month, and this includes the unlimited talk and text. Each company allows customers to use the same pricing rate for fewer or more amounts of data used each month. So MR Talk charges $99.99 for 10 gigabytes of data used per month, and MRS Text for 15 gigabytes of data charges $119.85 a month. So what we need to do here is kind of look at some ways that we can compare these two rates and figure out which one is best. One way that we can compare rates is to use a rate table, which is just a table full of rates, and specifically those are going to be equivalent rates or ratios. So let's look here. We have that in the top row of our rate table is the amount of gigabytes we use, and then we have a row for MR Talk Company and MRS Text Company. To fill out or complete the rate table, we can use proportions, and it's pretty much set up right for us. We know that 10 gigabytes of data is $99.99 for MR Talk, so we can start by figuring out what 1 gigabyte of data is. We know this. To solve a proportion, we're going to draw arrows from what we know to what we want to know. We're going to find our scale factor. In this case, we're going to take 1 divided by 10, and we're going to get 1/10. And we're going to take 99.99 and multiply it by 1/10, and we're going to get that 1 gigabyte of data costs $99.99, and we can put this into our rate table. Using the same thing for MRS Text Company, we find our scale factor here, which is 1/15, multiply that by 119.85, and we get that 1 gigabyte of data for MRS Text is $7.99. Now, to fill out the rest of this rate table, there's a lot of different options. You can set up 4 more proportions for each, or you can use the quantity for 1 and just multiply it. If I know that 1 gigabyte is $9.99, 2 gigabytes is going to be $9.99 times 2, which is $19.98, and so on. Go ahead and pause the video here, take a couple minutes to fill out the rest of your rate table. Alright, so here's what you should have for the rest of your rate table. MR Talk for 2 gigabytes is $19.98, 5 gigabytes is $49.95, 15 gigabytes is $149.85, and 20 gigabytes is $199.98. MRS Text for 2 gigabytes is $15.98, 5 gigabytes is $39.95, 10 gigabytes is $79.90, and 20 gigabytes is $159.80. We now need to go ahead and use this information, and one of the ways that we're going to be using this information is to write equations to represent our rate tables. So here's the rate table that we just completed. And for right now, we're going to use a little saying to help us write equations. And that saying is doing chores is smart. And each of the 4 words there stands for a different part of the equation. So we call this an acronym or a mnemonic device. The D is going to stand for dependent variable, so doing D, dependent variable. The C is constant rate of change, which you've also heard of, it's called CROC. The I is the independent variable, and the S is the starting value. And we'll review here very quickly what each of those 4 terms mean. So doing chores is smart is written D equals C times I plus S. The D, like we said, stands for dependent variable. That's the quantity that's dependent on the other one. It's not being controlled. Right? So I can't change this quantity. It all depends on what the other quantity is. The C is constant rate of change, also known as CROC. And that would be the amount the dependent variable or the Y value increases for every 1 that the independent variable or the X value increases. And the way I like to think about this is if the independent variable increases by 1, the dependent variable increases by blank, where blank is my constant rate of change. The independent variable is the quantity that you are changing or manipulating. This is going to control the other quantity. So in our example, the independent variable is going to be the amount of gigabytes used. And the starting value is the value of the dependent variable when the independent variable would be 0. In our examples here, we're going to see in just a minute we have a starting value of 0, but starting values represent things like setup fees or delivery fees or anything of that nature, typically one-time charges that aren't tied to a specific number of gigabytes or data used. So let's go ahead and write our situation, or write our equations here. Sometimes I list these things out in vertical format. For this, I've just put them into a table to help us see. So the dependent variable, the one that we can't control, that is dependent on the other thing. In this case, for both of our MRTalk and MRS text, is going to be our cost. However much it costs is going to depend on the independent variable, which we'll see in a minute, is the number of gigabytes used. Our constant rate of change is going to be the price for 1 gigabyte. So for MRTalk, the constant rate of change was $9.99 because every time we increased 1 gigabyte, we paid $9.99 more. For MRS text, the CROC was $7.99 because for every 1 gigabyte of data we added, we had to pay $7.99 more. As we just said, the independent variable here, the thing that we can control, is the amount of data we use, the gigabytes of data used. And notice beside the cost, I put a C. That's the variable I'm going to use to represent cost. And I have that one capitalized. And beside the independent variable, I put a lowercase g for gigabytes. And that's the variable I'm going to use to represent that. I said earlier we don't have any one-time fees here, no setup fees. So our starting value is 0. If we don't use any gigabytes of data in these plans, we don't owe any money. And so if we put this all together in dependent variable equals constant rate of change times independent variable plus starting value, we're going to have C equals $9.99 times G. And I could put a plus 0 on the end of these equations, but if our starting value is 0, it doesn't make sense to write plus 0. So for MRTalk, we have C equals $9.99 G, and MRS text, we have C equals $7.99 G. Once again, C being the cost, G being the amount of gigabytes used, and the $9.99 and the $7.99 being my constant rate of change, how much my price is going to increase for every 1 gigabyte of data that I use. The last thing we want to talk about is putting this all together is graphing an equation or graphing a set of data. When we do some problems in class, we're going to be putting multiple sets of data on one coordinate grid, and we're going to be comparing them. But for this video, we're just going to look at the MRTalk data. So when we graph things, you should be familiar with graphing things. There's some things we need to remember, and I'm going to go through this one by one. First thing is all graphs need a title. In this case, a good title might be cell phone rates. Second thing, we need to put labels on our x and y axes. So you should remember that the x-axis is always the independent variable. The y-axis is always the dependent variable. So in this case, my independent variables was gigabytes used on the x, or the left and right bottom axis. And the cost in dollars was my dependent variable that goes on the up and down or y-axis. Next thing is we need consistent units, meaning that each block on an axis is worth the same amounts. And I'm going to tie this in with the next bullet point there, which is include as much data as possible. So I'm looking at the MRTalk data. I go from 1 gigabyte to 20 gigabytes. So I want to try to put all of that on my axes. So I need to look at the x-axis, and I see that there are 10 spaces. I'm going from 1 to 20, and there are 10 spaces. So in this case, I'm going to count by 2's. Same thing for the cost. I'm going from $9.99 to about $200. So my range is somewhere between $0 and $200. Again, if I count up the y-axis, I have about 10 blocks. I need to go $200 in 10 blocks. That's about $20 per block. So on the y-axis, I counted by 2's. On the x-axis, I counted by 200's. Now this data is not the nicest to graph because it doesn't give us what I call pretty points that lie exactly on an intersection of my dotted lines, but that's okay. We're going to get these as close as possible. So I'm going to go through and I'm just going to plot the points. We've practiced doing this. 1 gigabyte is $9.99. So I'm going to move 1 on the x-axis and then up about 10 on the y-axis, and I'm going to do this for all my points, and you'll see that I would get these points here. Notice as my amount of gigabytes gets spread out from 1 to 2, 2 to 5, 5 to 10, 10 to 15, 15 to 20, my points get a little further spread out. Next, it's not good enough anymore to just simply plot the points. We want to connect these points with a straight line starting at the origin, and we're going to draw an arrow on the end of that line to the right because I could use more than 20 gigabytes. Now I can't continue my arrow to the left because I can't use a negative number of gigabytes. So it's going to start at the origin, meaning that I could use 0 gigabytes, and it's going to continue straight line through my points with an arrow on the right ends. Lastly, I want us to get into the habit of labeling our lines, especially as we start to put more than one set of data on a graph. In this case, I'm going to label it MRTalk. So we've covered a lot of information here. We've covered ratios versus rates. We've covered making a rate table to compare different rates. We've covered how to write an equation for a rate. And we've covered how to graph the equation or the rate table. As we go through class, we're going to be looking at many more situations involving this type of material, and we're going to be talking about some situations that have a starting value that aren't equal to 0, and we're going to be adding some terminology for these different situations.